Okay, I'm hoping everybody has this flowchart in their notes. I'm going to kind of zoom in here. So on one side of the flowchart, we see the alkenes can be turned into alkanes, haloalkanes, and alcohols through addition reactions. And then from alkanes, we can go to haloalkanes and amines and alcohols through substitution reactions. We can also see over here that there are oxidation reactions going to aldehydes, ketones, and then if going farther from the aldehyde to carboxylic acids, and we can also do further condensation reactions. All of these reactions have been covered in your notes, but for if some reason you're missing a part of this chart, you do have it, and I'm going to refer back to this chart. We'll also see two alcohols together plus a catalyst. In a condensation reaction is going to produce an ether and, of course, water. You always produce water in a condensation reaction. So what I want to look at next is some of the questions in your notes. So I'm going to look at the first one, and I actually highly recommend doing these on a separate piece of paper because it's kind of squishy in the notes. So in the first question, it says that you have 3-aminopentane and you want to make it from an alkane. So you're going to make it from pentane. Why pentane? Because you want 3-aminopentane. So you know you need 5 carbons, so it's probably a good idea to start with 5 carbons. So let's see, if I want to go from an alkane to an amine, what am I going to have to do? So let's look at the chart. Alkane, I add a halogen to get to a haloalkane, and then I add NH3 or an amine to get to an amine. Okay, I can do that. Let's go back here again. So here I'm taking pentane, and I want to add X2, but not really X2, some halogen. So I'm going to use Cl2 because that's the one I usually use. And I can put the chlorine anywhere I want on this molecule. And I'm going to put it on the 3rd carbon. And I'm going to put it on the 3rd carbon because I want to make 3-aminopentane, which means I want the amino group on the 3rd carbon. And it's going to go wherever the chlorine goes. So I make 3-chloropentane. Then I go to the 2nd step and I add NH3 in a substitution reaction. It replaces the chlorine, and guess what I have? 3-aminopentane. In both steps, I'm going to produce HCl, which I'm showing coming out as my second product, because when I pull off the hydrogen, it has to go somewhere, so it goes with the other chlorine. In the first reaction, when I pull off the chlorine, it goes with the hydrogen from NH3. HCl is a very common second reactant. In the next step, it says make butanol from an alkane in 2 steps. So I want to make an alcohol from an alkane. All right, let's go back to my chart. How do I do this? Alkane to haloalkane, add a halogen, to an alcohol, add water. All right, let's see if that's what I did. So with an alkane, I want to make butanol, so I need butane. Butane plus chlorine, because that's my halogen. Substitution reaction. I'm going to put the chlorine on the 2nd carbon. Why? Because I want to make butanol. So I want it on the 2nd carbon. Now the chlorine's on the 2nd carbon. I add water in a substitution reaction, and now I've made butanol. Notice, in both of these substitution steps, I'm making HCl. If you use chlorine in your first step, you're going to make a lot of HCl as your other product. So for this one, it says make 2-ethoxy, 2-chloropropane from 1 alkane and 1 haloalkane. You may not be at the stage right now where you know what alkane and what haloalkane to use. So I'm actually going to kind of help you out here. So I've written out and drawn out the diagram for 2-ethoxy, 2-chloropropane, which is an ether, because it's got an oxy in it, so I know it's an ether. Alkene, I'm going to use ethene, and for my haloalkane, I'm going to use 2,2-dichloropropane. I'd like you to pause the video right here, and I'd like you to try to figure out what the steps are. You're going to need 3 steps. 3 steps. So go to your diagram and pause and see if you can figure out what the 3 steps are going to be. I'm going to pull the chart out here in front of me while we do that. And we want to make an ether. So to make an ether, I need 2 alcohols. So if I have an alkene, I can make an alcohol. And if I have a haloalkane, I can make an alcohol. In both cases, I'm going to have to add water. Once I have 2 alcohols, I can make an ether. So let's have a look here. In the first step, I took the ethene, I added water. And in an addition reaction, it breaks that pi bond, puts in a hydrogen and an OH on either side, and I end up with ethanol. In the next case, I can see here I've got 2,2-dichloropropane. I'm reacting it with water in a substitution reaction. The OH replaces one of the chlorines, and I now have 2-chloropropane-2-ol, and HCl. Now, if I take these two and I put them together in a condensation reaction, remember right here, these two OHs are going to pull out of water. And water is going to get produced over here. And the two molecules that are left over are going to bond together. There's going to be an oxygen in the middle. And what am I going to end up with? Propane. So what am I going to end up with? 2-ethoxy, 2-chloropropane, plus water, because it's a condensation reaction. Follow the chart. Make sure that you follow where the substitutions are supposed to go. Make sure you make the extra product and follow the steps, and you will get to your answer.